All right, so in this video, we're going to run through some examples of types of problems of calculating, seeing if a molecule is polar or not. So, the question is like carbon tetrachloride, for example, is polar? Question mark. Okay, yes or no? And so how do we do this? First, we're going to come up with a Lewis structure. From that, we're going to get the shape. And then we're going to calculate the dipoles, okay, of bonds and see if the dipoles cancel. And so that's going to be the net dipole, right? Okay, so carbon tetrachloride, we're going to have to figure out the number of valence electrons. That's the first thing. 4 for carbon, 7 for each chlorine. That's going to get you a total of 32 valence electrons. And your Lewis structure, therefore, is going to look something like this, where you are going to have your 4 chlorines as terminal atoms, your carbon's less electronegative, so it's the central atom, and you're going to have lone pairs on all the chlorines. That will get you 2, 4, 6, 8, right? So that's octet rule for chlorine. 8 times 4, all the chlorines are identical. 8 times 4 is 32. That matches your 32 valence electrons, and your carbon also has 2, 4, 6, 8 octet rule satisfied. So that's the right structure. The steric number here is what we're going to have to calculate to help us get the shape. And that's going to be 4. There's 1, 2, 3, 4 bonding sites. There's no lone pairs on the central atom. And then you're going to have your steric geometry. That's going to be tetrahedral. That just comes from it being 4. And then you're going to have your molecular geometry. And since there's no lone pairs on the central atom, it's going to be also tetrahedral. Okay, so at this point now you have to figure out your dipoles of your bonds. And so you're going to look up the electronegativities, okay? And for carbon, you're going to look this up on a table, right? That is always going to be given to you on the exam. You need to know electronegativity trends, but you'll be given the table to calculate these types of values, right? So let's see, for chlorine, it is 3.2. Sorry, that's for chlorine. Chlorine is 3.2. And for carbon, it is 2.6. So if you subtract those, you're going to 3.2 minus 2.6, that's 0.6. That is going to tell you that it's a polar covalent bond. It's greater than 0.4 and less than 2, so it's not ionic, right? Polar covalent bond. Okay, so that means you are going to have dipoles, since the chlorine's more electronegative, pointing towards the chlorine in each of these cases. Okay, but the net dipole here is what we have to think about. And the net dipole is actually going to be nothing, because you essentially have 4 dipoles pointing out in equal and opposite directions, radiating equally from this tetrahedron. And so net, that is going to get you no dipole. So your final answer, right, for here is that this is a nonpolar molecule. Okay, and it's a nonpolar molecule because there's no net dipole. In other words, all these 4 individual dipoles cancel. It's equally radiating out from a tetrahedron. All right, we'll do some more examples in the next video.